Lake Amatitlan in the Department of Guatemala, nearly 5 leagues from the capital, is 3 leagues long and nearly 1 broad, with a great depth of water. It is admired chiefly as a bathing place, in which, in the months of February, March, and April, the inhabitants of the city and adjacent places resort, some in search of health, others for amusement. It abounds with fish, morasses, pepescas, and crawfish. These are esteemed delicacies. They are caught in great quantities, giving a considerable profit, principally by supplying the city during the whole year. They furnish almost the only food of the fish kind the inhabitants are acquainted with, as sea fish seldom reaches them in good condition. Near the lake there are several mineral and hot springs said to have curative qualities for rheumatic and other complaints. The Playa de Oro will be a living demonstration of what the lake was and will be. Playa de Oro is an existing lakeside public park in San Miguel Petapa, a diamond in the rough, which Fundaeco is transforming into a crown jewel ecological park. Our first step is plastic removal. Subsequent steps include planting butterfly and bird sanctuaries and the planting of thousands of trees along kilometers of roads and new paths. The new paths include a mountain bike loop trail. We will build a partially floating BMX and skate park, lookout cabins in the cliffs below Maya Gulf, which will be accessible by boats. We will add boats, docks, and swing platforms. Playa de Oro Park will include a swimming and fishing park. The park will become a fecund fishery producing hundreds and then thousands of fish, shrimp, and more per day, based upon a pollution to food built ecosystem in which sludge and algae form the bottom of a dynamic food web. The system will demonstrate efficacy to alleviate food insecurity by sequestering CO2. Our first Playa de Oro pilot was, being under the control of AMSA, mostly turned off. Even so, it developed thousands of fish, eliminated or biodredged 6 meters of sludge, revealing gorgeous black volcanic sand with gold specks. An implication of our demonstrated ability to eliminate all the sludge in Lake Amatitlan, thereby availing rich fish habitat, is that amati fish, etc., bred and evolved for tens of thousands of years in that very, now smothered, sand ecosystem, was the world's only relatively cleaner body of water within a relatively dirty body of water, was a fine swimming hole, enjoyed demonstrably improved visibility. Here is the first pilot where the visibility was when it was turned on from side to side and top to bottom, and we made it 6 meters deeper. This is what a local fireman that we hired had to say about it.
No, pero estas cosas de corazón son buenísimas.
Son buenas.
Mejor.
Sí, yo que tengo 36 años de vivir en Amatitlán, pues creo que con esto de haber hecho, voy a esperanzas de que el lago se recupere como estaba antes. Entonces es motivante para que sigan estos proyectos para que sea bien para el lago y para la humanidad completa.
Wastewater treatment plants require both a sewer system and sufficient land to hold the wastewater. The longer wastewater is held, the lower are the operational expenses. The sewer system is the largest portion of a typical wastewater treatment capital budget, and the holding capacity, i.e. the real estate and the wastewater treatment lagoons, is the second. The cost to build sewer would be in the hundreds of millions of USD. Imagine, there's Amatitlan, San Miguel Petapa, and so on. There's 2 or 3 million people whose discharge goes into the Rio Villalobos. The technology is a distant third cost, probably less than the financing cost of the first two. The solution. Thanks to Amatitlan's geography, Revive Amatitlan will be the cheapest wastewater treatment project in the world on a cost per kilogram of COD removed basis, and also prevented basis, which is maybe more important. We'll talk about that on slide 20. The Rio Villalobos and its tributaries provide our sewer system for free and now. the land and lagoons surrounding the river's mouth are sufficiently large to build the world's cheapest treatment plant, given the correct technology mix. Divert the river into the naturally existing lagoons through which the river currently flows and into which for thousands of years the river used to discharge. Remediate the flow in these existing lagoons before the flow enters the main lake. Eliminate malodors, remove nitrogen, phosphorus, and organics before the flow enters the lake. Remove sludge. Sludge must be removed both because sludge flux releases phosphorus and nitrogen back into the lake, and also because sludge smothers the fecund spawning grounds that existed for tens of thousands of years. This is the technological solution. So spinners pump pressurized air and water and algae into novel mixing hoses. Not shown is that spinners are also novel rotating biological contactors through which Kuchtal's induced flow passes. The Kuchtal aerates, draws in surface algae, thereby feeding the spinners with algae and surface water, blows surface water, air, and algae downwards, or benthetic air and sludge upwards, generates a continuous plume of imploding air and cavitation bubbles. Imploding cavitation bubbles lyse algae and sludge and dissolve oxygen. Lysed algae and sludge are easily and quickly digested, especially by the grow pod's biofilm, i.e. the grow pods and the bodies of everything else for that matter are aerated biofilm membrane reactors. Kuchtal's grow pods, spinners, and mixing hoses serving together are a novel aerated biofilm membrane reactor. Mixing hoses emit pre-mixed air, algae, and water slurry into the grow pod's completely dark inside center cores, wherein, being dark, the algae dies. Dying algae is metabolized by aerobic biofilm enveloping the porous grow pods. The expanding biofilm is grazed by all manner of aerobes whom, in turn, are consumed by predator fish thriving within the Kuchtal's downward plume of dissolved oxygen and lysed algae. Another part of the solution is to remediate the river directly with this device.
This is the world's first free river-powered aerator. In other words, where the aeration is derived from the power of the river. So here we can see water, air. I assume there's some mixing going on, so the water itself is probably aerated. And so, when this is scaled a little bit, then almost any river in the world could be revived and full of fish, no matter how polluted, because there will always be aeration. We just have to build in diffusers and higher pressure.
Spinners, flow or motor powered, aerate the river, thereby converting pollution into either sludge rather than algae before entering the sludge removal system, or by using grow pods, converting pollution into shellfish, water, and CO2. The shellfish would be grown in removable canisters filled with sand or another grow media within the grow pod, directly connected to the mixer hose, creating a highly aerated ecosystem with an anaerobic body of water, probably a world's first. Remove substantially more sand from the river because the slower the river flows, the more opportunity there is to remediate the river, and two, the only way to prevent the next hurricane from extending the river forward is to remove the huge volume of the already settled sand beforehand. For this plan to work, phosphorus must be mechanically removed from the river, lake, and sludge. Failing any of these, the lake will not recover. This is a consequence of the lake's phosphorus cycle, including that phosphorus, along with nitrogen and iron, promotes algae growth. And this gets back to the previous slide where we need to remove COD, but maybe more importantly, also remove, you could say, future or prevent algae growth. So how to remove phosphorus, etc. The system is a reef-like built environment in which continually harvested algae and sludge is the bottom of an aerobic food web, and as a consequence of which, harvesting fish sequesters phosphorus from the lake and CO2 from the atmosphere, as well as, of course, nitrogen from the lake. How not to remove phosphorus, and how not to bring back native fish. Aeration does not remove phosphorus. Aeration produces 10 times more sludge per kilogram of pollution removed compared to the same quantity of pollution removed anaerobically. Sludge oxidation removes all oxygen from the lake bottom, killing the lake's most important fish habitat. Aeration contributes to this dead zone by delivering fresh sludge. Sludge flux cycles phosphorus back into the lake, fertilizing algae growth. Sludge smothers critical fish breeding habitat. Please join us to demonstrate efficacy and costs to revive Amatitlan by developing the Playa de Oro swimming and fishing park.